I would like to follow the book Machine Learning written by Kevin Murphy. It is easily accessible in all the libraries and bookshops. We will cover these few topics in today's lecture. First of all, what is principal component analysis? Basically, with the help of principal component analysis, we are fetching the information, the most important features, or you can say pattern within the given data. In order to make a new variable, or you can say that the principal component. If we are talking about physique of a person, for example, height and weight of the person, we can encompass these two features. As height is one feature, weight is another feature, we can encompass or we can develop a new feature in terms of body mass index. And this one feature, basically principal component, with the help of linear combination, we are developing the body mass index. Furthermore, why we use the PCA? Of course, it helps us to reduce the dimensions. For example, we are 10 friends and we are visiting some shop and we are requesting for 10 ice creams. Instead of asking that the one ice cream, we are saying that one ice cream, again one ice cream, we will say 10 ice cream. Basically, this 10 is a linear combination of all 10 friends. So ice cream is a eigenvector, or you can say that the one vector, the 10 is the eigenvalues. So we are reducing the 10 dimension into the single one. This is the one, okay? So that is the linear combination of the isolated 10 ice cream, or you can say the 10 friends. So we are reducing the dimensions from 10 to 1, though it is the variable, or you can say that the new variable. Similarly, in terms of data visualization case, for example, in criminal case, we want to sketch some criminal with the help of few elements. You can say that the color of hairs, or mustache, or somehow, or you can say that the edges of the face, we can predict the particular person, or simply if I can say that there are the edges of a car frame, we can say it's a car. If the edges of a aeroplane frame, we can say it's the aeroplane. So data visualize can be done with the help of limited number of features. Of course, sometimes we are talking about the noise filtration, unwanted data, especially during the communication. We can say that the bird chirping, we could not notice, only the main focal communication can be noticed, or we can get rid of the unwanted data. One more thing about the feature extractions. For example, there is a dark place, or you can say that the dark night, though we have a good eyesight, but we cannot see the things without light. So important thing, the vital features are required to notice there. The vital feature in the dark is a light. So if there is no light, we cannot see, even we have good eyesight. This is the important thing. Let's give an example. For example, there are 6 points in 3D formations. Each, you can say that these 6 points, if we want to store in a computing system, we need 18 bytes. However, if we notice the first point is 3 times upscale in this point, 5th time upscale in this point, and 6th time upscale in this point. So we have 2, 4, 3, 5, 6 are the constant coefficient, and these 3. So we have total, how many we can right now bytes will be required to save this above data. So these are 3 in category. So there are the 5. So simply we can say this one the 1. So we total need 9 bytes, because 6 are the constant and 3 are these 3 the information. So 3 values. So 50% saving can be done. 50% in order to store the data in terms of a byte. We can reduce the 100% to 50%. Furthermore, it is very important how does PCA work. Of course, these are the few components I will see in the example. For example, if we want to capture the information of this T part in a maximum possible way, so what is the way? Of course, these three formation at the bottom does not help a lot. However, this one help a lot. Of course, we can get a maximum length horizontally as well as we get a vertical information. So there are two possible principal component of this to get the maximum information can be done or captured in image. Of course, there is another way that the variance how much differ from the mean position. For example, I got this picture from the PCA that there are three friends, Alex, Ben and Chris. Height of each person is different, and just with their shadow we can reflect that the A is the person who is the maximum of height. Of course, it's the Chris. If I am talking about the B, the lowest one, okay, they are standing at the same position, okay. So we can say that the minimum height, of course, B represent the Alex. So some conclusion with the help of variance that we know already the important characteristic, or you can say that the facial expression or style whatsoever, but this help out a lot. However, sometimes if all the person have a similar height, this is a problematic thing. Then this component, only component of height will not help us a lot. Therefore, we need to consider another component, and that component can be a weight factor. However, sometimes even the variance, okay, you can say that the difference between the mean position, okay, so it's almost similar. Then again, we are in a problem. So we may need to consider some another component, third component or fourth component. Let me explain the component. However, before going to explain the component, I would like to talk about the eigenvectors and eigenvalues. For example, if I want to predict the values of, you can say that the GDP, social life, freedom, generosity, corruption, values of different countries. I am talking about the stability of the countries, that of France, Denmark, India, or somehow like this. These GDP, social, these are the special segments in terms of eigenvectors. These are known as eigenvectors. The values, if GDP is too good, we can say that value is too good or eigenvalue is too high. If the GDP is low, we can say that eigenvalue, GDP is bad, you can say eigenvalue is low. However, in terms of component, we can consider the major component. For example, GDP, social values and the life stability, we can say these are the three major components. We are categorizing these. However, out of these three components, we can notice that the first one, GDP, is very important. If GDP is good, we can say that the country, we can predict about the life stability, we can about the social values. However, say therefore we can categorize or we can rank that the GDP is at the first rank, you can say that the life is at the second and the social value is at the third one. Furthermore, if we want to get rid of or we want to reduce the dimensions out of these three possible components, we can say that we can ignore the social one. We can say that GDP and the life is sufficient to talk about any country stability. However, further if we want to reduce the data, okay, we can say that if only GDP is sufficient enough to talk about any country, that how it is going good or how it is going bad, because it has some linear combination. So eigenvector, this GDP is having the first eigenvector, its value, or you can say that if the GDP is too good, we can say that the eigenvalue is too good, or we can say that the country is going in a good progressive way. Therefore, this eigenvectors and eigenvalue help us to predict the component, or you can say that the principal component. This principal component, GDP in its term, can categorize the country ranking. In order to summarize the principal component, we can say that the PCA may compare with writing a book. Remember, it's a two-step process. We cannot write a book summary if we have not read it out, or we do not understood the content of the book. Therefore, PCA similarly work like this. If we want to conclude the PCA, we need to understand, then summarize the data. In order to conclude, we can say PCA itself kind of a parsimonious thing. We need to comprehend the data, or we need to limitize the data in order to reduce the computational cost, or computing power, less computing power can be used, or estimate the original source. Of course, our principal component must reflect the original data. In one another thing, data cleaning process can be done beautifully with the help of PCA. We can get rid of the unwanted noise. Though PCA is a very beautiful topic, if it is possible, you should get a time to read it out in terms of mathematics. Okay, of course, there are few segments, eigenvalue, eigenvector, variance are involved in it, and you will enjoy a lot. Thank you.